Hi, this is our product, EcoSmart, and it's an object AI tool that can be used to basically detect objects and sort trash from recycling. Oh, there's no audio on our video.
Okay, wait.
Let's go.
But now, our Earth's beauty is simply breathtaking. But now, every year 90% of the Earth's waste goes unrecycled. If we continue neglecting our environment, parts of the world will be uninhabitable by 2050. However, there is hope. With our AI tool, EcoSmart, people will be able to easily sort trash from recycling. With EcoSmart, we hope to begin combating these problems and helping save our Earth.
Shout out to Vishal for doing the really deep voice. That took like a couple of tries, I know, and that was awesome. Um, So basically, what is it? Like I said, it's an AI tool that can easily sort trash from recycling as an initiative to help make the earth more green and help combat the amount of waste that we produce. Like all object detection databases are, it's very extensive, consisting of thousands of images of bottles, cans, plastic bags, and many other recyclable materials. EcoSmart can accurately find these objects in photos and videos or pictures in order for humans to sort them. So, how we can help the world? Much of the world is covered in garbage dumps, and parts will, like the video said, even be considered unlivable in 2050. A lot of the trash that enters those garbage dumps comes in through a conveyor belt. So, we believe if we put a camera on there, then it'll become a lot easier to combine it the efforts of human intelligence and an AI like EcoSmart in order to better sort the trash from recycling. So right now there are some similar AI object detections that sort trash from recycling at UC Boulder, I believe it was. CU Boulder. They had something where you could throw your trash in a trash can and robotic arms would automatically sort your trash and recycling. But that's a very small scale solution. EcoSmart is meant as something that can be done with minimal cost and effort to create a large scale solution. And with our database of more than 3,000 images, it makes us different in that we can confidently identify objects that are meant to be recycled, despite if they may not look exactly like all of our pictures. So like I said, the way it works when the trash comes down that conveyor belt, we can have a camera set up, or even if people have their phone screens, they can look through and see which are the trash and which are the recycling. So it becomes much easier to sort through all that nonsense.
So for our dataset collection, we use SERP API. SERP API is a tool that helps us gather images from various pages and search engines. We can then define the search queries in SERP API to specify the type of image we want, like plastic bottles or plastic bags. SERP API would then automatically fetch these images for us based on the search queries we defined. The queries that we defined were aluminum cans, batteries, plastic bags, plastic bottles, cartons, tires, and glass bottles. And then we used RoboFlow, and RoboFlow is the platform that we use to label and prepare our images for a model. For labeling in RoboFlow, we drew bounding boxes and added class labels to our images to help train our model. Our dataset consists of 1,640 images and roughly 250 per class. The benefit of using these programs is that SERP API saves time by automating image collection, and RoboFlow streamlines labeling for accurate annotation. Overall, this improves our efficiency in creating our model.
So after labeling, we added various augmentations to our images. We put it to 3 times augmentation so that there are 3 total outputs per image. The specific augmentations that we added were rotation between negative and positive 45 degrees, blur up to 1.5 pixels, noise up to 10% of pixels, and a bounding box that rotates 90 degrees clockwise, counterclockwise, and upside down.
And the object detection model we are using is YODO VA large. And YODO VA is an anchor-free detection model. And anchor-free detection is a technique used in computer vision to find and locate objects in image or videos. And the hyperparameter we are using is 150 atoms and 640 times 640 resolution and 64 batch size.
All right, so let me just hide that real quick. Here's our website. Vishal and Serin put together a lot of this front end stuff, and then we have the try our product button right here, which allows you to upload an image such as like a milk carton, a battery, anything like that, and it'll detect the like object and put a bounding box around it like this. And then we also have a webcam functionality. So let me just turn that on real quick. I have to turn my camera off. This lets you capture an image. It even works on like your phone, for example. It'll take about 5 seconds, but it'll put a box around that. And we even had it to where you can like just take a picture with your camera and have it predict around. It'll take a little bit. Yeah, that's about it on the website part. Our metrics, we had a F1 curve at around 0.8, and here's our confusion matrix right here.
In addition to what Lucy showed us, we also have the Hugging Face model where we can upload a video. We'll just use like this example here because it'll take very long otherwise. So you can see the original video looks like this, and then the process video shows how it's a plastic bottle, it's a plastic bag, and the plastic bottle is being picked up. Okay, so some future uses for this model would be activities like beach and stadium cleanup. We could use LAM to add our software to drones and for a larger scale so we can detect objects from an aerial view. We hope that EcoSmart can continue to combat these issues of our environment in the future. This is our team. As Nayan mentioned before, Vishal did add the background, not background music, that was Bauer, said the voiceover for the video, and then Bauer created his own music for the background, so I thought I'd mention that. Lucy and Nayan were the project managers, and then the rest is self-explanatory. Thank you for listening.